In the tropical landscapes of Southeast Asia, Thailand stands as the world's leading producer of natural rubber. Covering approximately 3.53 million hectares, its vast rubber plantations generate around 5.4 million tons of natural rubber annually. Making up over 35% of the global supply. This extensive production is crucial to the global market, supporting industries worldwide that rely on rubber's unique properties. From the tires gripping the road to the gloves used in medical facilities, Thai rubber plays a vital role in modern industries. But how does this go from tree sap to an everyday product? Let's uncover this journey together. Welcome to Agriculture Unwrapped. Let's embark on the discovery of Thailand's rubber empire. The journey begins deep in the plantations before the sun rises. Before dawn, skilled farmers move through rows of rubber trees. Using a technique called rubber tapping, a tapping knife is used to carve a precise groove at a 30-degree angle, allowing the latex to flow without damaging the tree. The milky white liquid drips into small collection cups, typically made of coconut shells or aluminum. A single tree yields about 50 to 100 milliliters of latex per day, roughly half a cup. However, with each tree producing latex for over 30 years, the supply from large plantations adds up significantly. The rubber tree is incredibly resilient, and its ability to continuously provide latex makes it a key resource for sustainable production. On a large rubber farm, thousands of trees are tapped daily, ensuring a continuous flow of raw latex that is then collected for processing. Timing is critical. Farmers begin tapping in the early morning when cooler temperatures ensure optimal latex flow. As the day heats up, the latex thickens, reducing efficiency. Within a few hours, the flow stops naturally as the tree seals its wound, and farmers move on to the next tree. Once collected, the latex is transported to processing facilities where the transformation begins. Transportation is usually done in large containers to prevent premature coagulation, as exposure to air and certain contaminants can cause the latex to solidify before reaching the factory. This careful management of latex quality ensures that it will be suitable for the production of high-quality rubber products. Fresh latex contains around 60% water and 40% rubber particles. Making it too fluid for immediate use. To solidify it, farmers add formic acid, which lowers the pH and causes the rubber particles to coagulate into a soft, sponge-like mass. This process takes 6 to 12 hours, depending on temperature and acid concentration. The resulting rubber mass is then carefully handled to ensure uniform quality and prevent contamination, which can affect the final product's durability. This step is crucial, as even the smallest impurities can compromise the integrity of the rubber and make it less durable in end-use applications. The coagulated rubber is then rolled into thin sheets using hand-cranked or motorized rollers. These rollers remove excess moisture and create a ridged texture, making the sheets easier to handle and transport. Many farms air dry the sheets for several days or use smokehouses to speed up the process and prevent mold growth. The distinctive smoky smell of natural rubber comes from this traditional drying method. Smoke curing also enhances the rubber's durability and resistance to microbial degradation, extending its shelf life before further processing. This method has been refined over generations, with modern farms adopting both traditional and newer techniques to maximize efficiency. The rubber sheets proceed to factories for refinement after completing the drying process. The washing process removes any remaining dirt and residual acids from the rubber sheets. The rubber sheets undergo shredding, followed by drying to eliminate all moisture content. The final step ensures that the rubber is prepared for further industrial use. The combination of these processes guarantees that only the highest quality material moves forward in the production chain. The processing industry mainly focuses on technically specified rubber, TSR, because manufacturers transform it into large blocks for convenient industrial transport. TSR is preferred for its standardized quality, making it ideal for tire production and other industrial applications. The rubber undergoes final quality checks to verify its elasticity, tensile strength, and overall quality before receiving industrial approval. These tests are crucial to ensuring that the rubber meets stringent standards. as any deviation from the specifications could result in a significant loss of product performance. Global natural rubber production exceeds 4 million metric tons annually, with a major portion used in tire manufacturing. Rubber requires a vital strengthening procedure known as vulcanization, which was invented by Charles Goodyear in 1839. Heating rubber to temperatures between 280 degrees Fahrenheit and 320 degrees Fahrenheit and adding sulfur forms cross-links, transforming the material into a durable substance that can withstand extreme temperature conditions. Through vulcanization, rubber maintains its elasticity, resisting both cold brittleness and heat-induced melting. The final properties of rubber depend on sulfur content, typically between 2% and 5%. Vulcanization transforms rubber into durable, flexible materials, allowing it to perform effectively in various environmental conditions. Accelerators and antioxidants protect rubber from UV rays and chemical agents, enhancing its durability. Rubber becomes ready for manufacturing after completing the processing and strengthening stages. The tire industry is the largest market for natural rubber. Big manufacturers blend rubber with carbon black to improve durability. The rubber is shaped and exposed to high temperatures, resulting in durable tires. Modern tires are made of multiple rubber layers, combined with fabric and steel reinforcements to ensure safety, stability, and an extended lifespan. Rubber shows its versatility in applications such as shock absorbers, conveyor belts, sports equipment, and waterproof gear. Shock absorbers in vehicles reduce vibrations, improving ride comfort and extending vehicle lifespan. Rubber's strength and flexibility make it ideal for conveyor belts that transport heavy materials in factories and mining operations. Its elasticity helps sports balls like basketballs, footballs, and tennis balls perform consistently. Rubber also provides water resistance and insulation, making it essential for medical gloves and wetsuits. Benefiting professionals across various industries. The combination of flexibility and pressure resistance in rubber makes it essential for numerous applications. The expanding market for rubber products motivates researchers to develop more efficient and sustainable production methods. Scientists work to develop sustainable latex-producing plants, such as dandelions and guayule, to decrease dependence on traditional rubber trees. The development of recycling technology has brought about improvements that enable used rubber products to be transformed into new applications. Thus reducing environmental damage. The evolution from latex drops in trees leads to everyday products through a process that unites natural resources with scientific advancements in industrial production. The rubber industry remains dynamic because scientists work to create sustainable rubber production through forest protection and better recycling systems. The growing global rubber demand drives innovations in processing alongside alternative rubber sources, including synthetic rubber and bio-based alternatives to fulfill world needs while protecting the environment.